Hey guys, welcome back. Most of you may already know I love sandwich ITX cases. I think the Dan Cases A4 SFX first drew me in back in 2016. I fell in love with how the compact sandwich layout was able to showcase the expensive components on both sides. As GPUs got bigger and bigger over the years, so have the cases needed to fit them. With the latest ASUS Noctua 5080, this is no different. So I set myself a target to make the world's first sandwich layout ITX case that can fit the 5080 Noctua GPU. Now, before we start, this is going to be a long video, so I wanted to throw up some time cards for the final assembly, Glam Shots, and even the noise testing towards the end. I'm also happy to announce that the project files for this build will be available on my Etsy linked in the description. With all that out of the way, let's get on with another MXC builds.
Let's start with the rear panel. 3mm Jara ply cut to rough size. We'll combine 3 layers of plywood for the rear. I chose to use multiple layers to get the desired final thickness. Cutting on the laser. Layers glued together while drill bits make sure they are aligned. Main groove was cut in the inner layers only. Cleaning up the edges. Solid Jara will be used to cover the exposed plywood sides. There's never enough clamps around here. Glue squeeze out is carefully planed off. It's critical to plane in very shallow passes as to not damage the thin veneer on the plywood. Excess is trimmed, then plane flush. Trim to final width. .6mm birch ply is used for the spline to match the Noctua theme. Off to the laser. The piece was too long to fit, so the cuts were completed manually. Lines extended before using the jigsaw. This hole will only be drilled through after the glue up. Surrounding area is masked and plenty of glue is used. Once dry, we can drill out the hole. Scrap wood is clamped on the area to prevent splitting. Threaded inserts go in. Again, Jara will be used for the frame as it matches the Noctua brown very well. I wanted to rip the whole board to width first before cutting it into segments. To do this, I have to move my workbench to act as an outfeed table for my table saw. The setup was tested before actual cutting. Nerves were quite high when ripping such a large piece. The end with a split was trimmed off. Then, the face with the least defects was chosen for the outside. Frame segments cut the length on the miter saw, followed by beveling the edges on the table saw. Thickness of the rear rabbet marked. Nice. I used the CNC to cut the spline groove as it was easier than manual routing. Position traced and checked before milling. The groove was a bit tight, so I enlarged it by 0.2 millimeters. Perfect. Big milestone here, seeing all the pieces lined up for the first time. It's always good to check all the miters meet up tight before glue up. Button and USB holes were machined as well. Inner chamfers given to all edges. The radiator slot pattern was cut on the laser with a 2mm smaller center and crosshairs for alignment. The slot center position was marked on the timber. Outline of the smaller size cutout was transferred over. This jelly white pen worked real good for dark wood. I messed up this hole here, but hopefully we can get rid of it later. The rough shape cut out. The negative template is now stuck on and a pattern following bit is used. Repeated the same for both slots. Chamfering the edges. Scrap panels were used to set the height of the bit for the indent. Then the piece was stuck onto the table. It's helpful to leave a lip so it's easier to remove later. More scraps stuck around a rectangular shape of the radiator indent. The slow routing process begins.
One eternity later.
Edges cleaned up and then carefully removed from the table. Rear inserts added. Surrounding areas protected. Ample glue applied. Tape used to keep the joints closed. Clamps to help with any stubborn gaps. saw marks sanded off.
So the case is finally glued up. I think it's now time to try fitting on the GPU and the power supply just for a sanity check.
Bracket holes needed some minor adjustments.
For the power button, I usually cut a small piece of wood and stick a brass rod through it and then mill it on the drill press to get a concave finish. But this time I want to make it out of a solid piece so I don't have the luxury of spinning it around and machining that concave. So I'm going to try and do it on the CNC. Let's have a go.
Blank prepared. Faced. And a concave machined. It came out nice. These were cut from the same 3mm Jara ply. MXC logo was darkened by first applying clear to reduce bleeding, followed by black. The 3mm ply is quite flexible, so a spar and ribs will reinforce them. Using the good old super glue baking soda trick. Magnets will make these covers easily removable. Pressed into the top and the mating piece glued into the spar. Initial tests showed the cover is not exactly perpendicular to the top panel. A dab of glue and soda forms a little nub. The nub was made oversized, then tuned to fit. Perfect. Then the internals were painted black. More ply was mitered and then joined to form a shroud in two halves. This design needed a shroud to hide a lot of the cables. The other half had more complex cutouts for some special cable management you'll see later. Exposed edges were colored black to match the other panels. Radiator top slats were cut from solid hickory. Blank was resawed to 6mm thickness before ripping to slats. I made sure to number them in order to preserve the grain pattern. Trim to length, then edges rounded. Gave them a sand and chamfered the edges. Slats glued into these printed brackets. All the parts were coated in a hard wax oil. Felt furniture feet attached. USB and button glued in. The build will mostly use Noctua parts, but there are a couple that needs matching. Gold accents from the previous motherboard was covered with Jara. For the AIO block, I'm gonna try something different. Let's extract the Noctua logo from this packaging. Gently rubbing under running water will remove most of the cardboard carrier. Result is a paper-thin label. This was clamped to dry out flat, then trimmed to size. The edges are still white from the backing, so we simply color that in. Spray adhesive works well for this application. Now we're ready to assemble the build.
Before we get started on the final assembly, I've listed the full build parts down in the description below along with their Amazon affiliate links. Purchasing parts through these links gives me a small kickback at no extra cost to you. Thank you for supporting the channel.
Center spline removed. Case flipped over to install the radiator. Four custom brackets hold it in. Noctua A12 G2s installed. Cables extended. Fan hub stuck on the back. Some minor cable management. Spline goes back in. The motherboard has the CPU and M.2 drive pre-installed from the last build. The CPU power and PCIe extension is also connected at this stage. Extension and power is threaded through the back. Fan header is also ran under the board. CPU cable fed back to the front and 24 pin connected. CPU block installed, followed by 64 gigs of RAM. The block cables were looped around to conceal them as best I could. The power button and USB header was connected. Now for the single part that took the longest to design of the entire build, this cable tray module. The part was printed in a single piece using Prusa's new Noctua Beige PLA. There is an underside channel for hidden cables to pass through. Slight rewind, the module design was only finalized after the construction began. So to easily mark the mounting points on the spline, I cut out a template with a few reference holes out of paper and transferred it onto the wood. The USB and button cables will run through the underside channel. The module is screwed on in 4 points. custom combs inserted. It was so satisfying pressing these cables in. The comb for the 28 pin was designed to accommodate the uneven number of cables per row. This made sure all the cables sat evenly in the top row. Front USB plugged in.
So the cabling is going well, but we sort of have another problem. We're gonna have to make that fit.
A tube holder bracket was designed and printed with Noctua colored PLA. Bracket attached with 4 screws from the back for extra strength. Tube stand secured neatly. That's better. Now the ASUS Noctua 5080 can go in. My dovetail GPU mounting system is used again. Additional bracket for the front as this is a very heavy GPU. Tab bracket installed loosely. Then dovetail bracket holds it in place. The front bracket takes up the sag. Unfortunately, the screws ruined the clean look I'm going for. Good thing I designed these internal divots and a matching cover that gives a super clean look. GPU power is connected and ran through the tray. Satisfaction maxing right here. Noctua Seasonic 1600 watt PSU slides in. Instead of mounting holes in the rear panel, I chose to use a sandwich type bracket which clamps the PSU against the rear panel. Cables connected. I'm very happy with the fitment of this shroud. Same for the other side. Radiator covers snap on. These connections look kind of messy. Don't worry, I've got something just for that. A shroud with mesh cover for added detail. Oh look, a coincidental magnet. Snaps right in. Same with the fan connection section. Fine adjustment of the spacing of each cable. I also thought the front area felt a little empty, so I added another decorative mesh panel. Another wood piece was used to cover the PCIe connection. And finally, the radiator slats slide in and are held in using these clips. So again, the CPU cooler is the limiting factor in this build. I really hope there will be a 360 AIO that can silently handle some high-end CPUs at max load. The GPU ran extremely cool, never reaching over 70C, and the fans were whisper quiet.
So, what do you think? Did I capture the essence of the sandwich layout ITX case in this build? Let me know what you think down in the comments below. If you've enjoyed the video, drop a like, share the video, or even subscribe to the channel. All the support really means a lot to me. As always, thank you all for watching right till the end, and I'll see you in the next build.